Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSE, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. The series of lectures cover about mobile and pervasive computing. The lecture series cover cellular wireless networks, global system for mobile communication, GSM architecture, GSM protocols, connection establishment, frequency allocation in GSM network, GSM handover, security in GSM, and the general packet radio service, that is GPRS. The content of today's session is about the GSM protocol architecture. The GSM protocol architecture consisting of the following layers: radio layer, link access procedure for D channel, that is referred as LAPD layer, radio resource management layer, mobility management layer, call management or CM layer, base transceiver station management layer, base station subsystem application path layer, pulse code modulation layer, and the signaling system number SS7. In the previous lectures, we have already discussed about the following 3 layers of GSM protocol architecture. That includes radio layer, link access procedure for D channel, and radio resource management layer. In today's lecture, we will discuss about the remaining GSM protocol layers. They are mobility management layer, call management layer, base transceiver station management layer, base station subsystem application path layer, pulse code modulation layer, and the signaling system number, that is SS7. Let us have a small introduction about the GSM protocol architecture. The protocol is nothing but a set of rules and regulations that governs the entire operation of the GSM network. Now, the GSM protocol architecture has many interfaces. interface is a one that specifies the connections between the mobile stations and the tower, and ABIS is an interface that specifies the connection between BTS and base station controller. Like that, we have the A interface that specifies the connection between base station controller and the mobile switching center. Now, the mobile station has the radio layer, LAPD M layer, radio resource layer, mobility management, and call management layer. Let us discuss about the mobility management layer now. The mobility management layer handles the control functions required for mobility. It controls, it manages registration, authentication, identification, location updating, provisioning of a temporary mobile subscriber identity, that is referred as TMSI. GSM provides mobility to its subscribers. So, whenever the users are moving from one tower to another tower, that is from one coverage region to another coverage region, they have to be identified, located properly. Now, the mobility management takes care about locating, registration, updation of the mobile users. The users has to be authenticated. Whenever the users are entering into the new coverage area, the GSM network has to identify the right users. That users has to be authenticated for security issues. The mobility management layer provides the TMSI number. Actually, the TMSI replacing the international MSI number. We know that the users are connected through the radio layer. So, radio layer has many problems with security issues. In general, the GSM network should not show the real identity of the user. So, now the TMSA replaces the original identity of the user. So, over the air interface, the original identification of the user will not be provided. Instead of that, the GSM mobility management layer will assign the TMSA number. So, using this number, the users are identified in the visitor location register, that is VLR. And mobility management offers reliable connection to the next higher layer. So, the next higher layer to the mobility management layer is call management layer. So, the data should not be lost. Such a reliable connection should be assured to the next higher layer. So, the next layer in the GSM protocol architecture is call management or CM layer. Now, call management layer is used to set up the call, maintain and take down the calls connections. Once the call is over, that established channel should be collected back. Now, the CM layer is consisting of three subgroups, that is call control, SMS service and the last one is supplementary service. Let us discuss one by one. The call control layer provides the point-to-point connection between the entities in the GSM network. So, when a mobile user is making a call to another one user, maybe for a fixed or mobile user, that call has to be established. So, that is referred as the point-to-point connection. Now, the call control layer takes responsibility of establishing the point-to-point connection. It is used by the higher layers. Now, the higher layers are using the call control layer for providing the call establishment, clearing the call, changing of the call parameters. Very attractive feature of GSM network is SMS service. Now, the SMS service is supported in the call management layer. SMS allows message transfer using the control channels. So, generally the GSM network is not using the dedicated data channels for providing the SMS service. Instead, it uses the control channel for providing the SMS service. SMS offers guaranteed message delivery for mobile station. GSM users are provided with a guaranteed delivery of SMS. If a mobile station is switched off and that particular period time, some messages may be forwarded to the particular mobile station. The moment the mobile station is turned on, that already sent messages will be delivered to the mobile station. So, that kind of reliable data transmission is achieved for the SMS service. And GSM expects some acknowledgement from the mobile station to the GSM network. The call management layer also provides the supplementary services. They are multi-party service or conferencing, call waiting and call hold, call forwarding, number identification, advice of charge, closed user groups. So, GSM offers the conferencing facility. So, 3 or more number of users can be connected in the same period of time, that is referred as the multi-party or conferencing call. And call waiting. Call waiting is a service that intimates a user about a new incoming call. For example, if a person is making a call to another one person, so the call will be established. Once the call is established, some person may try to the same number. At that time, the user will be intimated through the call waiting service, and a GSM user can put the call on hold and hold call can be resumed back. And call forwarding, in most of the times for particularly the salesmen, they will not be free, so they will forward the call, incoming call to some other number. So, the main aim of call forwarding or call redirecting is to avoid losing of the calls. Number identification. in many times the called or calling person's number should be identified. So, GSM offers various kind of facilities for identification of the GSM numbers. So, using this facility, the calling person's number will be displayed or presented to the subscribers. Sometimes the malicious users may call to some other persons, so they can disturb. So, in these kind of situations, the malicious users can be easily traced. So, the users has to subscribe into the number identification service. So, the malicious call can be traced and that identification can be sent to the authority for further action. Advice of charge, that is referred as AOC. This service is used to intimate the users about the cost for the used services. So, closed user groups, it is referred as HUG, sometimes HUG plan. 2 or more persons can be subscribed into this service. So, with some discount or with some reduced tariff, they can make a call between them. So, that is known as the closed user groups. The next protocol architecture layer is PCM, pulse code modulation layer. Physical layer uses pulse code modulation for data transmission. So, the PCM is used by the physical layer of the GSM network for data transmission. Now, PCM is used in 2 communication channels. First, BTS, that is base transceiver station and base station controller using the PCM for their data transmission, as well as the base station controller and the mobile switching center uses the pulse code modulation for the data transmission. So, a physical layer at the A interface typically has the connections with 2.048 megabits per second. So, it is the capacity of that leased line. So, in the protocol architecture, now the PCM layer is used in the A interface. So, the BSC and mobile switching center are using the A interface to transmit the data, as well as in the ABIS interface. Now, the BTS and base station controller using the pulse code modulation for the data transmission. So, in the GSM protocol architecture, 2 versions of LAPD layers are used. So, LAPD-M and LAPD. Now, LAPD-M is the modified version of LAPD that we have already discussed, that is specified in the interface. We have the LAPD also. Now, LAPD is the link access protocol that is specified in the ABIS interface. Now, the data link layer or the LAPD between the BTS and the BSC is used to specify the access mechanisms between the BTS and the BSC. We have the 2 versions of the LAPD layer. Let us start our discussion from LAPD layer. Link access procedure for D channel. LAPD is implemented in layer 2, that is data link layer at A-BIS interface. It provides reliable link between 2 network entities. The data should not be lost. Even for a lost data, the error handling mechanisms has to be clearly handled. Now, LAPD assures the error handling mechanisms. The main functions of the data link layer are establishing, maintaining, tearing down the link and flow control as well as error detection. Sometimes 2 entities in the GSM network will not be with the same speed. So, the flow control should be provided properly to avoid the data loss. So, LAPD layer is defined in the data link layer or layer 2. So, ABIS using LAPD layer to provide the communication between BTS as well as the base station controller. Let us have a short break. We will continue our discussion after the break. Welcome back. Before the break, we have discussed about GSM protocol architecture, that is the mobility management layer and call management layer has been discussed, as well as the pulse code modulation also discussed. Now, let us start our discussion from the base transceiver station management, base station subsystem application part, signaling system number, that is SS7. Also we have completed the link access protocol in the previous session. So the GSM architecture using the SS7 signaling system number 7. This standard defines various kind of activities for the operation of the entire GSM network. We know that the wireless users are connected to the GSM network, fixed GSM network, and fixed GSM network is connected to the public switched telephone network, public data network, ISDN network. Various entities of GSM network and the entities from the outside network has to be operated very well. SS7 specifies the detailed specification about the entire interconnection. PSDN, ISDN networks exchange the information with the GSM. Wireless cellular and wireline call setups are handled by the SS7. So mobile users are making the call. So mobile stations are connected with the cell phone tower. Now cell phone towers are controlled by the base station controller, that is by the BSC. Many BSCs are controlled by the MSC. So MSCs are connected with the PSDN, ISDN network through the gateway MSC. Now SS7 specifies the multiplexing principles, how to forward the call, how to activate the call between the entities. And one more important point about the SS7 is routing and control. So routing has to be controlled in a very clear manner. The calls has to be routed to the right destination. It has to be generated properly. Now let us discuss about the BSSAP layer, that is base station subsystem application part. It provides reliable sequenced delivery of call control messages over connection oriented data link between BSS and MSC. BSS are connected with the MSC, that is mobile switching center. Now reliable sequenced delivery is a mandatory required service. So the control messages may be transmitted, sometimes they may be reached in out of sequence. So that out of sequence of data has to be arranged in a proper manner. Now that is handled by this layer. It assures the in order arrival and performs retransmission of lost packet. If a packet is lost, that lost data has to be recovered properly, else the users will miss some informations. So the BSSAP layer is used between BSS as well as MSC. So it is a kind of control data. So it specifies, it transmits the control information between BSS as well as MSC. It generates and checks a per packet checksum to catch transmission errors. If an error is occurred, the BSSAP using the checksum operation. So checksum is nothing but a mechanism of detecting the transmission errors. For individual packet, the BSSAP generates the checksum, and using the checksum the error will be catched. So in the diagram, BSSAP is used between base station controller and mobile switching center. So it is specified in the A interface. So error checking mechanism and maintaining the sequence of data transmission between base station controller as well as mobile switching center is specified in the BSSAP layer. The next layer in the GSM protocol architecture is BTSM, that is base transceiver station management. Base transceiver is nothing but the cell phone tower that has to be managed, controlled properly. Now the users are connected with the BTS, BTS are connected with the BSC. So base station controller to the base transceiver station is specified in the A base interface. So it allows sending the messages between the base station controller and the BTS. Control messages from the BSCs are sent to the towers to monitor the call, to perform the handover operations are controlled through the BTSM layer. Almost we have discussed about the protocol architecture of the GSM. Now let us combine the GSM protocol architecture with the GSM functional architecture. In the previous lectures we have discussed about the GSM functional architecture, That functional architecture contains various kind of sub networks: radio subsystem, network and switching subsystem, operation subsystem. Now the various subsystems are using the interfaces and the protocol architectures. Here we will consolidate all the operations of individual protocol layers. Now the mobile station is connected with the BTS, that is the tower, using the interface. Now the BTS is connected with the base station controllers using ABIS interface. Now BSC is controlled by the MSC using the A interface. So radio layer is the first layer in the GSM protocol architecture that specifies the connection between the wireless users and the tower. It handles the security issues, it identifies the user, and the radio layer is one that specifies the medium access control layer. So how long the particular frequency band is allocated to the user. So that is specified by the radio layer. It manages the radio resources. So next layer is LAPD. In the GSM protocol architecture we have two LAPD versions. One is LAPD M and LAPD. So actually the LAPD is the link access protocol that is derived from the link access protocol of ISDN network. The LAPD M version is the modified or it's subset of the LAPD layer that specifies the link access mechanism. So the radio layer will assess the channel and based on that it will give the report. So as the next higher layer, the link access protocol will take some decisions. So that is specified in the LAPD M layer. And next one is radio resource management that manages all the radio related issues. The channels has to be established properly, established channels has to be monitored properly. Once the call is over, that channel has to be taken back. Radio management is handled by the RR or radio resource management layer. Next, mobility management. We know that the GSM users are able to move from one place to another place. So now mobility is supported by the mobility management layer. While supporting the mobility, the users has to be located, they have to be identified. So all kind of mobility related issues are dealt with the mobility management layer. Call management layer specifies three kind of entities: call control, SMS as well as supplementary services. So various kind of supplementary issues we have already discussed. So the main supplementary services supported by the GSM network is implemented through the call management. So that is the point to be noted. So the actual supplementary services supported by the GSM network is implemented through the call management layer. Through the supplementary services, the users are subscribing into various kind of services. They can avail the call forwarding, call hold as well as conference call facility. Closed user group facilities are provided by the GSM network. The mobile station is working with the interface with a bundle of protocol architectures. Now BTS is connected with the mobile stations. Now the BTS has the collection of protocols, pulse code modulation. You can listen one thing, the BTS is contacting with the BSC using pulse code modulation, but for the wireless part the BTS is using the radio layer. So two kinds of protocols are used in the BTS. So one is for managing the radio transmission and one is used for transferring the data through the wires. So in BTS, two versions of LAPD is integrated. One part is used to manage the radio related issues as well as the one part using the LAPD version, the BTS is making connections with the base station controller and BTSM. So BTSM is a protocol that is used in the ABIS interface. Now the BSC, that is the base station controller, is using the BTSM protocol to control the BTS. Next interface in the GSM architecture is A interface. So the A interface is connecting the base station controllers with the mobile switching center. So the individual lines between the base station controller and the mobile switching center is with the capacity of 2.048 megabits per second. Signaling protocols are used in between the BSCs and the MSCs. Base station controllers are connected with the MSC using the signaling system number 7. So how the call should be forwarded, so all the things are specified in the SS7. So SS7 is also used to connect the entire GSM architecture with the outside network. In the protocol architecture, the outside network like PSDN, ISDN are not mentioned. So SS7 is used within the entities of the GSM protocol. Now BSC and MSC are the two entities of the GSM protocol. SS7 is also used between the GSM network as well as the outside network. So in the MSC also we are using call management facilities and mobile management facilities and BSSAP, that is BSS application part. So this is the overall view about the entire GSM protocol architecture. In the radio resourcement layer we have two versions, one is RR and RR dash. So in the diagram, RR is specified in the mobile station and RR dash is specified in the BTS. Some part of radio resource layer is mentioned specified in the BTS and some part of RR is specified in the MS. The mobile station is consisting of the protocols used to manage the mobility. So the mobile station are vulnerable to many kind of security issues, so that real identity of the user should not be exposed to over the air interface. Mobility management layer provides that kind of support. So it assigns the TMSI number. The pulse code modulation between the BTS and BSC is using the leased lines, and the individual leased lines are with a capacity of 64 kilobits per second. So far we have discussed about the entire GSM protocol architecture. Let us summarize what we have discussed. LAPDM performs reliable data transfer, resequencing of data frames and flow control between BTS and MS. So flow control is the mandatory mechanism to avoid the data loss as well as reliable data transfer. Resequencing of data frames is a mandatory one, because the data frames will be transmitted in sometimes with the out of sequence. That out of sequence data has to be rearranged in the receiver side. So LAPDM in the UM interface takes care of resequencing of data. Radio resource management layer performs the setup, maintenance and release of radio channels. So with the demand of users, the radio channels are to be allocated to the users. The allocated radio channels are to be monitored, and after the call is over, that allocated channels has to be collected back for providing the channel to the next users. Mobility management layer handles the control functions for mobility. So we know that GSM provides mobility support to its users. Users can roam around, users can move from one location to another location. So that kind of mobility is supported using the mobility management layer. Temporary MSI, that is temporary mobile subscriber identity, is used in the GSM context. So we cannot show the real identity of the mobile user on the air interface, as it is vulnerable to many kind of security issues. So the temporary MSI number is used by the GSM to hide the real identity of the user. Call control provides point-to-point connection between two terminals. So two mobile users or one mobile user with a fixed network are known as the two entities. Now these two entities are using the point-to-point communication. The connection or the channel is established between the two terminals. Data transmission between BTS and BSC as well as BSC and MSC uses pulse code modulation. Pulse code modulation specifies the data transmission on the leased lines with the specified capacity. So BTS and BSC, so these are the two entities, they are using the pulse code modulation, as well as BSC and MSC, two entities of GSM using the pulse code modulation. mobile switching center controls BSS via BSS application part. BSS AP is the protocol that is specified in the interface that is used by the mobile switching centers to control the BSS. BSS is a collection of various towers. So, now through the BSS AP protocol, a mobile switching center can control many base transceiver stations. So, AB's interface connects base station controller with the base transceiver station. So, it uses base transceiver station management protocol to control the BTS. So, we know that many cell phone towers are connected with the base station controllers. So, the BSTM protocol should be implemented in the AB's interface. So, the control messages from the single base station controller can be transmitted to the many BTS of the particular BSC using the AB's interface. Let us put some questions for our understanding. Question number 1. Identify the interface that connects the mobile station with the global system for mobile communication backbone network. Question 2. Identify the various types of interfaces used in the GSM protocol architecture. Question 3. Differentiate LAPD and LAPD-M. Question 4. How does the real identity of a mobile station is hidden over air interface? Question 5. What is pulse code modulation? Question 6. List the GSM supplementary services. Question 7. Why does the base station subsystem application part use checksum? Question 8. Identify the functionalities of SS7 in global system for mobile communication. With this we conclude today's session. In the forthcoming sessions we will discuss about the other issues related in the GSM network. Thank you.